So when we're solving equations by factoring, we just want to remember what solving means. Solving means that you're going to find the roots or the zeros or the x-intercepts, and this is going to happen by setting y or f at x equal to 0. So let's look at some examples together. If I wanted to find the zeros for something like 3x squared plus x minus 10 equals 0, you'll see that y equals 0 has already been plugged in for us into the equation, which means that we're trying to find the x-intercepts or the roots, which will be helpful when we're graphing. So looking at 3x squared and negative 10, two terms that multiply to 3x squared would be 3x and x. Two terms that multiply to negative 10 would be negative 5 and 2. And when I cross over, I end up with 6x minus 5x, which is 1x. So using harder factoring, I came up with my two factors. 3x minus 5 times x plus 2 should work nicely if I'm converting the standard form into factored form. So I'm going to be able to now use that factored form, again setting y equal to 0, and then each of those brackets need to be set to 0 because 3x minus 5 could be 0, or x plus 2 could be 0, because if it was 0 times a number or a number times 0, you would have 0 overall. So we would end up with 3x equals 5, or x is 5 over 3, which is 1 2/3 if you were trying to graph it. We can just leave it as 5 over 3, or x plus 2 equals 0, so solving for x could be negative 2. So my two x-intercepts are 1 2/3 or negative 2, 0. Remember that you can factor a complex trinomial either through crossover method, which I just showed you, or through decomposition. So I'll show you how to do the next one with decomposition. So if I had something like 4a squared plus 21a plus 20 equals 0, I could again look at factors of 4 and 20 and use the crossover method like I just did in the previous example. Or with this harder factoring question, I'm going to just show you how to use decomposition as a quick review. So with decomposition, you're looking for two numbers that add to the middle term and multiply to the product of the first and the last term. So in this case, that would be 80, multiply to 80 and add to 21. And so I'm going to leave the first term alone and the last term alone. But what I really want to do is I want to take that middle term and break it up into those factors that we just talked about. So two numbers that multiply to 80, I could use 16 and 5, because 16 times 5 is 80, and they also add to 21. So I'm just going to break down the 21a into 16a plus 5a. And then with decomposition, what I can do is I can look for a common factor in the first group of terms. So in the first group of terms here, I can pull out a 4 and an a, and I'm left with a plus 4. And in the second group of terms, I can pull out a 5, and I'm left with a plus 4. So I have this really nice common factor. It's a binomial common factor of a plus 4. That I can pull out. And I'm left with 4a plus 5 equals 0. So a few more steps, but I have it in factored form now. So I'm just going to make this a little bit smaller so that I can get my final answer in here just like this. So now I can set both of those equal to 0. So a plus 4 could be 0, which means a is equal to negative 4 when you solve for a, or 4a plus 5 equals 0, which means that 4a equals 5, and a is, negative 5, and a would be negative 5 over 4, or negative 1 1/4. If we want to work backwards, given the roots, So if we're given a quadratic function, we know that in factored form, we're going to have two brackets. We're going to have an x in each of those brackets. One of the roots is -2, and the other is 3. Remember when we solve for the roots, we change the sign. So if you have x minus 2 equals 0, that would mean x equals 2. But we want to end up with -2, so we're going to make this a plus. So my first factor is going to be x plus 2. And likewise, if I want to end up with x equals 3, I have to make this x minus 3 equals 0. So I'm going to have x minus 3 in my second bracket. And I know there's going to be a y in my equation, and there's going to be some stretch factor here. So I'm going to call that a. There could be a coefficient of 1, 2, 3. There's infinite number of choices that all have the same roots and just have a different coefficient that's been pulled out, or a different constant that's been pulled out front. So in order to solve for that, we also have some other information. We know that it passes through the point 0, 12. So I'm going to sub 0, 12 into my equation. So x is 0 and y is 12. So 12 equals a times 0 plus 2 times 0 minus 3. And multiplying out, I would end up with 12 equals, let's see, a times 2 times -3. So 12 equals -6a when I multiply everything together on that right-hand side. And dividing both sides by -6, I end up with a equals -2. So my final equation then, the quadratic equation, is y equals -2 times x plus 2 times x minus 3. And if you wanted to check that the y-intercept was correct, you could take the last term in each bracket, so 2 times -3 is -6, and multiply it by -2, and you should end up with +12, which we do.